Welcome back. We're continuing to deal with slope-intercept form equations. So what we're going to do is we're going to be given a linear equation in slope-intercept form, and we're going to want to graph it over here on the Cartesian plane. So let's look at a few examples. Let's say we have y equals 3x minus 1. 3x minus 1. Now, how do we graph this? Okay, well, let's recall what our slope-intercept form means. It comes in the form mx y equals mx plus b, where m is called our slope, and b is the y value of the y-intercept. Okay, it's this value right here. So we can pick out these components out of the equation that we're given. So this is going to be number A. All right, so we have a slope of 3 here. We need this and this. We have a slope of 3 and the y-intercept of a minus 1. Okay, so let's graph this thing. We know that our line is going to cross the y-axis at the point 0, minus 1, so right here. And it's going to have a slope of 3. So we can start drawing it from here, and a slope of 3 is essentially 3 equals 3 over 1. So if you want to write it like this to see the rise over run a little better, we can do it like that. But it's going to go up 3 for each movement of 1 in the positive direction on the x-axis. So from right here, we're going to go up. We're going to go, oh, excuse me, let me get another color. We're going to go up 1, 2, 3, and over 1. So our line is going to look something like this. It's going to go in that direction, and it's going to go in this direction. And these two lines are going to continue infinitely in both directions. This is line A. And you see how we got this? We started with our y-intercept at 0 and minus 1, because that's our b value, our y value of the y-intercept. So it's crossing the y-axis at y equals minus 1, and it has a slope of 3. So for every movement of 3 we go up, every 3 spaces that we rise, we're going to move over 1 space. And we're just going to do that in both directions. Okay? Very straightforward. Just take one step at a time. Let's take a look at another one. Let's say we have y equals minus x plus 2. We want to graph this thing. Well, we know that the y value of the y-intercept is 2. It's going to cross the y-axis right here at plus 2. And the slope here is going to be minus 1, or a minus 1 over 1. Okay, so from here, we know that for every drop in 1, we're going to go over in the positive direction 1. So it's going to look something like this. And this is going to go in both directions. Now again, it doesn't matter if we put the minus sign for the numerator or denominator. It actually works the same in both directions, because they both go infinitely in both directions. So we also want to put these arrows on the end. And this line is B. So we have the line going through the point 0 and plus 2, and the slope is going to be a minus 1. And you can see that it indeed slopes downward. Okay, let's look at another one. Let's look at C. Let's say we have y equals 4 over 3. Excuse me, 4 over 3. Okay, so what does this mean? Well, we don't have an x term, so we assume that our slope is 0. 0 is the only number for the slope that we can multiply by x, and we don't have an x anymore. So we're only left with a y-intercept here. So this means that we're going to have a horizontal line. Anytime we have a slope of 0, we have a horizontal line. And it's going to cross through the point y equals 4, 3, or y equals 1 and 1/3. So positive 1 and 1/3 is somewhere right here on the y-axis, and we're just going to have a horizontal line. Okay? A horizontal line, all horizontal lines actually have a slope of 0. So it's going to look something like that. And they're going to continue in both directions infinitely. Okay, so we don't have a slope here, we just have a y-intercept, so that means we have a horizontal line. All right, let's take a look at another one. Let's say we have y equals 1 over 6x minus 5. Okay, 1 over 6x minus 5. I actually like it when the slope is given in fraction form, because As you saw up here, it's easier to deal with the slope when we're actually graphing the line, because we can see rise over run. Every movement we go up 1, we go in the positive direction 6 on the x-axis. So we're going to start at the point -5. This is the b value, the y value of the y-intercept. So 1, 2, 3, 4, 5. So this is -5, and for every movement we go up 1, we go over 6. So 1, 2, 3, 4, 5, 6. Okay, well actually that's not on the line at all. Let's try that again. 1, 2, 3, 4, 5. So we're starting here, and we're going something like this. There, that's pretty accurate. And this is going to occur in both directions. There we go. Going infinitely in both directions. And there's our line. So we start with the y-intercept. We know the line is going to cross the y-axis at y equals -5. And we have a slope of 1 over 6. So we're going to go up 1 and over 6. And likewise, in the same direction, the negative direction, we're going to go down 1 and over 6 if they're both negative. So remember, 1 over 6 is equivalent to -1 over -6. So this is why it's the same in both directions. We can go down 1 in the negative direction and to the left 6 in the negative direction. So that's why this equation is linear. It goes equally in both directions. Okay, let's look at another one. Let's say we have y equals 2.5x. Okay, here we're not given a y-intercept, so we don't know that this line doesn't cross the y-axis. Okay, so what that means is we're actually going to have, or it crosses the y-axis, but the y value of where it crosses the y-intercept, the y-axis, is 0. So what this means is it's going to cross through the origin, okay, or the point 0, 0. So whenever we don't have a y-intercept, the line's going to go through the origin, because the b value is the y value wherever the x value is 0, which is also known as the y-intercept. So this line's going to go through the origin, and the slope is 2.5. Well, let's rewrite 2.5 in fraction form. 2.5 is 2 1/2, which is a mixed number, and we can convert this into 5 over 2, which is an improper fraction, and this gives us a rise of 5 and a run of 2. So starting at the origin, we're going to go up 5 for every movement we go over 2. So 1, 2, 3, 4, 5. So we're going to go up 5 and over 2. And this is going to extend infinitely. So something like that. And it's going to go in both directions. And that was not in line. Let's try that again. There we go. Excuse me. So we got this line going in both directions infinitely. This is the line y equals 2.5x. All right, let's look at the next one. Let's take a look at, let's say we have y equals x plus 5. Okay, so here we have a slope of 1. We have an understood 1 in front of x, and which is the same as 1 over 1. So for each movement of we go up 1, we go over 1. So we're going to start at the y-intercept of plus 5. That's where the line crosses the y-axis. 1, 2, 3, 4, 5. And we're going to go up 1 and over 1. Up 1 and over 1. And this goes infinitely in this direction. And just like y over 1, or 1 over 1 is the same thing as minus 1 over minus 1. And that just proves that we can go in the other direction. We go to the left 1 and down 1. And we keep doing that, and it looks something like this. Okay, and these both extend infinitely in both directions. And there's our line for y equals x plus 5. All right, let's look at another one. Let's say we have y equals 2x plus 2. Okay, so 2x plus 2. So that means we have a slope of 2, or 2 over 1. And the line is going to cross the y-axis at y equals plus 2, which is right here. So for every movement we go up 2, we go to the right 1. So it's going to look something like this. Going to go up 2 and over 1. And if you want to think of it, if we're trying to draw the other side, we can think of it as -2 over -1. So for each movement we go to the down 2, we go to the left 1. So this is going to run through that point right there. And this isn't quite drawn to scale, and that's why the line is actually a bit crooked, but we can use a little imagination and imagine this is a straight line. And this is G. Okay, let's go ahead and do one more. Let's take a look at, let's say we have y equals -2. Y equals -2. Now again, we're left without a slope. There's no x term, so we just have -2. So what this is going to do is we're going to have a similar line looking as line C, this pink line. We're going to have a horizontal line that runs through the point y equals -2. So it's going to be something like this. Recall, all horizontal lines have a slope of 0. So there's no x term, which means we have a slope of 0 here, running through the y-intercept of -2. Okay, so what are we doing here? We have slope-intercept form equations for these linear equations, and we're trying to plot them on a graph. So what we want to do is we want to identify a few components. We want to identify the slope, and we want to identify the y value of the y-intercept. Okay, the y value of the point where the line crosses the y-axis. So once we identify these things, we can use these pieces of information to construct a line. Okay, very simple, very straightforward. We just want to make sure that we're familiar with these components. We'll be seeing slope-intercept form much more in the near future. So I'll see you soon.